Hello and welcome to this presentation. This is the third assignment for uh, AI Product Management Specialization course from Duke University, and the topic of my application is land survey using computer vision. So the agenda for today's presentation is we'll be talking about the task analysis, user experience design, privacy considerations, and ethical considerations. So the task at hand is to perform the land surveys that are critical for infrastructure projects, but are manually conducted at this point in time, which leads to a lot of errors and delays in the project delivery. So the the identification of tasks that are involved in the current projects are manual steps in the manual land survey is planning the survey, then collecting field data using maps and manual inspection, recording and reporting of that collected data. The insights that we have from task analysis is that manual surveys are time consuming and are error prone, and there is a need for efficient, accurate, and real time data collection methods. User experience design. And so for designing the application, we need to consider the user experience, how they will capture the data, what are the things that will help them to make it easy. So for capturing the data, engineers will be using their mobile devices to capture high resolution images and videos. The app will process these images and videos in real time using a CNN machine learning model. And for the feedback, it will provide the immediate feedback on identified features and highlighted areas needing further attention. Engineers can correct or annotate features and provide feedback to improve the model. The key AI specific considerations, so the inputs and the outputs. For input, we definitely need high resolution images and videos that will be used as the inputs, and annotated outputs with identified features and confidence levels will be returned as the output. So the if a user has captured a video which with cycle track and a road track, a rail track crossing. These kind of objects are present, trees are present, so they will be marked individually and annotated clearly as the objects identified through the machine learning model. For the transparency, clear explanation of the model decisions, confidence scores, and interactive elements for query decisions will be provided. There is a need for communicating uncertainty so that the confidence level can be boosted for the users. So confidence levels displayed on outputs, color coded for clarity. These kind of experience features, UI features will be used. Prompts for user validation in case of low confidence areas. So in case machine learning is not able to judge an object, clarity is needed. So a prompt to the user will be provided where they will input their feedback. And the feedback loops, real-time corrections are possible, and user feedback to continuously refine the model. Moving to the next slide, privacy considerations. So since we are we are scanning the area, there is a high possibility that we end up scanning cars, we end up scanning properties in the process. And as per the GDPR compliance, we are not allowed to display this information in public domain. So we have to be careful while making the scans that those vital informations are blurred out, so the data privacy risks are reduced. So there is a risk of capturing personal data and images in video, like I mentioned, and it's under the GDPR compliance here in Europe. We at times we might even need to take the measures like data anonymization and data encryption will be used to transfer the data and store for transferring the data. And yeah, user consent at times if we are making a scan of the area where there is a property and we need to access the property, the user scans will be user consent would be required for that, and we'll use that consent to make the progress. Ethical considerations, well, there's a potential source of bias that can come into the output of the machine learning model. The bias can be in training if data is not diverse enough, and the variability in environmental conditions can affect the model performance. The mitigation strategies for these biases will be to use a diverse training data set and bias detection and correction, which becomes very essential in case bias is detected, that it should also be corrected. So we implement algorithms to detect the bias and correct it, and we conduct regular audits for model performance. Goals of ethical AI is to provide fairness, accountability, and transparency. So that is it for the presentation today. Thank you for joining.